All right, today we're going to pull back the curtain on Python functions. We're going to uncover some of these hidden rules about arguments and scope, the kind of stuff that creates seriously confusing bugs and can trip up even seasoned developers. Okay, let's just dive right in. So, we're going to start with a puzzle, a little mystery. It's centered on this super simple function called addItem. All it's supposed to do is add an item to a basket. Seems easy enough, right? Well, just watch what happens when we call it twice.
The first time we add an apple, we get string apple. Perfect, that makes sense. But the second time we add a banana, and we get string apple, string banana? Wait, what? The apple is still there? What on earth is going on? Well, to solve this little mystery, we have to start by getting our vocabulary straight.
Yeah, it all starts with this really fundamental difference between parameters and arguments. I promise, getting this terminology right is the very first key to unlocking how functions really work under the hood.
It's actually pretty simple when you break it down. Parameters are just the placeholders in the function's blueprint. The arguments, those are the actual values you hand over when you use the function. So think of it this way. One is the variable name, the other is the actual value that fills it.
Here's a perfect example to make it crystal clear. In def add xy, x and y are the parameters. They're just empty slots waiting for data. But when we actually call add 3, 4, the numbers 3 and 4, those are the arguments. They're the real deal, filling those slots. It's a simple distinction, but believe me, it is a critical one. Okay, so now we know what arguments are. Let's look at how we can pass them to a function. Python actually gives us 3 main styles, and each one has its own set of rules.
First up, you've got positional arguments. With these, order is absolutely everything. Then, we have keyword arguments, where you match them by name instead of their position. And finally, we've got default arguments, which are super handy. They act as a fallback if you don't provide a value yourself.
But here's a rule that is set in stone. When you mix them, positional arguments have to come first. You can't put a keyword argument and then try to sneak a positional one in after it. If you do, Python just won't have it. It'll throw a syntax error because the order is now totally ambiguous.
So what do you think happens if a function is expecting 2 arguments, say length and width, but you only give it 1? Python is really strict about this. It checks the number of arguments, a concept known as arity. And if they don't match up, you get a type error. It's basically Python telling you, hey, you didn't give me enough information to do my job.
All right, we've built our foundation. We get parameters, we get arguments, we know the different types. Now, let's circle all the way back to that weird bug from the beginning. It is time to solve this mystery. Here it is again, our addItem function with its default basket parameter set to an empty list. So we call it once with apple, and then right after we call it with banana. Now that we know a bit more, what is really happening under the hood here?
And there it is again, apple, banana. The first item is still hanging around because the basket wasn't new, it was reused. And this happens because of one of the most famous or maybe infamous gotchas in all of Python.
This is it. This is the whole thing. It's called the mutable default pitfall. That empty list, it's not created fresh every single time you call the function. Nope, it's created once, when Python first reads the def statement and defines the function. From that moment on, every single call to add item that doesn't provide its own basket is using and changing that exact same list in memory.
So, how in the world do you avoid this trap? Well, the professional accepted best practice is to never use a mutable object like a list or a dictionary as a default argument. Just don't do it. Instead, the pro move is to default to none. Then, inside your function, you just check for none and create a brand new list if you need one. This makes sure that every single call starts totally fresh.
Okay, so we've solved the mystery of how values get into our functions, but what about the other side of the coin? How do functions find the variables they need to work with? For that, Python launches what I like to call a search party, and it has a very specific plan, all governed by its scope rules.
And that plan is called the LEGB rule. When your code needs a variable, Python searches for it in a super strict order. First, it looks in L for local, right inside the function you're in. Not there? Okay, it checks E for enclosing. That's any functions that wrap the current one. Still no luck? It moves on to G for global, the main top level of your script. And finally, if all else fails, it checks B for built-in, which are the names Python just knows automatically, like print or len.
This code demonstrates the search perfectly. Check it out. We have a variable named x defined in 3 different places, globally, in the outer function, and again in the inner function. When that inner function calls print x, Python starts its search. It immediately finds x in its own local scope, and it just stops right there. It found what it needed. It never even bothers to look at the enclosing or global versions.
So the most important thing to remember about LEGB is where that search always begins, right there in the local scope. Python always looks for a variable in its immediate vicinity before it ever considers looking somewhere else.
And what happens if that search party comes up totally empty-handed? If Python goes through local, enclosing, global, and even built-in, and it still can't find the name you asked for, well, it has no choice. It gives up and raises a name error.
Oh, we have covered a ton of ground, from the arguments you pass in to the variables a function has to hunt for. So let's just boil all of this down into a few key takeaways to really make sure this knowledge sticks.
Just remember these 4 rules. 1. Parameters are the blueprint. Arguments are the real materials. 2. You can pass arguments by position, by name, or use a default. But just remember, positionals always come first. 3. This is the big one. Never use a mutable object like a list for a default argument. Use none instead. And 4. When Python looks for a variable, it follows that LEGB rule, starting local and working its way out.
You know, mastering these rules isn't just about fixing some weird bug you might run into. It's about gaining a much deeper fluency with the language itself. This knowledge becomes a permanent part of your developer toolkit, and it's what lets you write cleaner, more predictable, and just plain better code.
So, I'm going to leave you with this question. I want you to think back to your own projects. Think about those moments of just total confusion, those why on earth did it do that bugs. Now that you know these hidden rules, what magic in your own code can you finally explain? Thanks for joining this explainer.